gated channel is closed, at that time the resting membrane potential is minus 70 millivolts. At that time, so outside of the neuronal membrane, that means it is what? It is what? Extracellular fluid. This place is called extracellular fluid. In the extracellular fluid, so more positive ions, more positive ions, more positive ions. So the sodium ions gradient, concentration gradient is raised. Why? Here sodium ion gated channel is closed. Due to the closing of sodium ion gated channels outside of the neuronal membrane, that is extracellular fluid, positive ion, positive indication, electropositive indication is more, then ultimately sodium ions gradient, concentration gradient is more. That is called resting state. That is called polarized state. Polarized state. So this is what yesterday only we discussed. Its conclusion I did not say yesterday. Time is finished. So now this is when we were in resting state. In the membrane, axon membrane, sodium ion gated channel is closed. Therefore, outside of the neuronal membrane, so more and more positive ion is maintained. Therefore, sodium ion concentration gradient is higher. At that conditions, what happened? That is called polarized state, resting membrane potential. Okay, that's up to this. Next one is now yesterday's continuation. Yesterday heading is resting membrane potential. That's continuation is conduction of nerve impulse along the axon or nerve fiber. The transmission of nerve impulse occurs by the following four ways. Among those, first one is initiation. Initiation of nerve impulse. Initiation of nerve impulse. When we touch hit, that is called initiation of nerve impulse. That is the first. So initiation of nerve impulse. Second one is transmission. Of nerve impulse. NI means nerve impulse. Transmission of nerve impulse along the nerve fiber, along the nerve fiber. How that is? See, already everybody knows that. Okay, when we apply stimulation, initiation, and then the nerve impulse is started. Nerve impulse is initiated. Nerve impulse is initiated. That will be received by the neurons, then runs to the cell body to the axon or nerve fiber. Okay, initiation. Next, transmission. Next, transfer of nerve impulse to the effector muscle or nerve. See, transmission, transfer, both are same. Transfer of nerve impulse to the effector. See here, nerve terminals will be there. Nerve terminals will be there. So from these nerve terminals, it goes to the effector muscle or nerve, another nerve. From this, it goes to the here, another neuron dendrons and muscles. So that nerve impulse, whatever we touch, whatever we prick, what I pinch, whatever we touch, prick, any sensation, that is the nerve impulse. Transfer to the effector muscle, or in the muscle nerve. So it shows its effect shows effect on tissues. When the nerve impulse reaches to the muscles, that nerve impulse shows that action on our tissues, our body tissues. Okay, so in such a way, impulse is passed. See, conduction means transfer of nerve impulse along the nerve fiber. See here, see in this region, stimulation. Initiation of stimulation occurs. Initiation of stimulation occurs. Or initiation of nerve impulse occurs when threshold stimulus is applied to the neuron. Listen carefully. Initiation of nerve impulse. See, first when I touch, when I bend, at that time what happened? Initiation of nerve impulse here occurs. When threshold stimulus applied to the neuron. Threshold means excitability. So initiation of the nerve impulse occurs when excitability or threshold stimulus is applied to the neuron. Excitability is applied to the neuron. So when the excitability occurs to the neuron, when we beat, when we touch, when we press, when we prick. Okay, initiation of nerve impulse occurs when threshold stimulus applied to the neuron. When we will apply threshold stimulus, that is called stimulation of nerve. When stimulation will be due to the nerve, at that time what happens in this particular place on the nerve? What happened? The axon, this is axon. The axon undergoes depolarization, repolarization. Excitable, come to original state, resting state. The axon undergoes depolarization and repolarization. When it happens, initiation of nerve impulse occurs. Initiation, starting of nerve impulse occurs when excitability will be due to the nerve or axon. Okay, initiation of nerve impulse occurs when the threshold stimulus is applied to the nerve. So now I have given excitability to the nerve. Excitability I have given to the axon. At that time, in this particular place, axon undergoes depolarization and repolarization due to the changes in the membrane permeability. This is membrane and this is membrane. Due to the changes in the membrane permeability, this membrane permeability result action potential. Okay, so when you will give threshold stimulus to the axon, inside the axon, what will take place? That is what now I will show in the form of diagram. See, once again I will repeat this point. See, initiation of nerve impulse occurs when threshold stimulus is applied to the neuron. Applied to the neuron means axon. At that time, this place, the axon undergoes depolarization and repolarization due to the changes in the membrane permeability. Due to the changes in the membrane permeability. As a result of this, it generates action last point, this point in the form of diagram I will show. See here. Then rods. Here, same like this. I am applying threshold stimulus to the axon. So at that time, originally here what? Plus, plus, plus. Negative, negative, negative. When it is minus 70 millivolts, when we were in resting state. Now we applied stimulation. On stimulus, this axon undergoes depolarization. After depolarization, it goes to repolarization. That is what I should see here. Depolarization. The axon undergoes depolarized. Depolarized means excited. When it is excited, the axon undergoes depolarization and repolarization due to the changes in the membrane permeability. Membrane permeability means what? Here positive became negative. Here positive became negative, positive became negative. Here this negative became positive, negative became positive, negative became positive. So this condition leads to action potential. How? See, it will be this positive is attracted by negative. This is attracted by negative. Here again positive, 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 negative, negative. So it will be attracted by this. It will be attracted by this, and so on. So positive, positive, negative, positive, negative. Here, action potential is generated. This action potential, how much? 55 millivolts. 55 volts, 0.55 millivolts of electricity. Initially resting state it was minus 70. Minus 70. So here minus 55 also. That means it is resting state. Resting state, this membrane potential is minus 70. When slowly initiation happens, at that time minus 70 becomes minus 60, minus 60 becomes minus 55. Initial stage of stimulus. When that stimulus is reaching to peak, then it becomes plus 55, not minus 55 to 60. In some books they will give 55, in some books they will give 60. But in between 55 to 60 you can write it. Okay, so resting state the membrane potential minus. When I am sitting leisurely. At that time, when we are sleeping, at that time minus 70 millivolts. When starts waking by any others, hey, Afzal, get up like this. When we are pressing, then automatically stimulation starts. At that time, it slowly starts to 55 to slowly minus 70 to minus 60, minus 50, minus 55, minus 40, minus 45, 0. Thereafter again, plus 10, plus 20, plus 30, plus 40, 50, 55, 60. I will show that graphical representation. Okay, that's it. So here, threshold, stimulus, depolarization, repolarization. First, depolarization. It is resting state. Plus, negative, negative. It is depolarized. During depolarization, when we will apply stimulus, at that time what happened? The membrane potential. The membrane permeability is changed. Then the axon undergoes depolarization. Excited. Okay. At that time, the action potential is released. About action potential. action potential. See here. Potential change. Potential change. Potential means positive, negative change. Potential change across the nerve membrane that occurs on stimulation of nerve is called action potential. This is the definition of action potential. The potential change. The potential change. Here, positive became negative, negative became positive. This is called potential change. The potential change across the neuronal membrane that occurs on stimulation of nerve fiber is called action potential. This is the action potential definition. Action potential definition. When stimulations are applied at a particular place, there is a disturbance occurs at a particular place, at a particular stimulation, and it brings about a change in the potential at that particular area. Once again, this point. When stimulations are applied, when stimulation means what? When we hold tightly, when we shake a hand, when we pinch, when we pet, like that is called stimulation. In our language, it is beating. For neuron language, it is a stimulation. When stimulations are applied to the neuron, a disturbance occurs at a particular stimulation, and it brings about change in the potential in that particular area. That is, this is the definition one. Second one is, when stimulations are applied to a neuron or axon, there is a disturbance occurs at a particular place. There is a disturbance occurs at a stimulation, and it brings change in the potential in that particular area. Change in potential in that particular area. So this leads to, these changes leads to here, this membrane permeability change. When potential is changed, automatically the membrane permeability also change. So this membrane permeability is changed. Then what happens? Sodium ions, more and more sodium ions are entered in from extracellular fluid to axoplast. So the permeability of the membrane is changed. At that time, what happened? More and more sodium ions are entered inside from this is extracellular fluid to axoplast. How more and more sodium ions are entered from outside to inside? In this one, sodium ion gated channel is opened. So resting state it was closed. At that time, more and more sodium ions are became. From the resting state, immediately it goes to excited state. So during excitable state, so outside the sodium ion gradient is more. Yesterday also I said this point. So when the sodium ion concentration is more, at that time these are all the sodium ions are from extracellular fluid enters inside. So at that time what happened? I said earlier, sodium ion gated channel is opened. So here sodium ion gated. In your textbook like this symbol in this diagram given. In the diagram like this lines drawn. But this indicates correctly this will close. Now this will be opened. So at that time, sodium ions are entered inside. Outside to inside. Outside in the sense from extracellular fluid to exoplast. Okay? So let's see. When it is happening, happen when stimulus is applied to the neuron. There is a disturbance occurs on that stimulus and brings about change in the potential in this area. As a result of this, the permeability of the membrane changed. Then sodium ion gated channels are opened and more sodium ions are entered inside from extracellular fluid to exoplasm. Okay, so this is that. Fourth one, the permeability of the membrane progressively less. Permeability of the membrane progressively less. Initially minus 70 millivolts, I said. The permeability of the membrane progressively less. It goes to minus 70 to 60, 50, 30, 0. Then again, from 0 to again 20, 40, 50, 55 to maximum 60. So here I should write 60 millivolts. The permeability of the membrane progressively less. From minus 70 millivolts to its reach to plus 60 millivolts. This change in the potential is called action potential, and this membrane is said to be depolarized. Okay, for better understanding, so this is I will show in the form of graphical representation. This diagram is loading. I will erase it. So I will show this is clearly we can get clear understanding. So graph time. So initially 0, minus 70, 60, 40, 20, 0. Next, plus 20, 40, plus 20, 40, 50, 60. So, resting state minus 70. So, gradually, I already said that resting state it was 70, when slow initiation happens, then it becomes minus 55 millivolts. Okay, so 72 minus 55. When initiation happens, it is 55 minus 55. So slowly, this indicates membrane potential. So progressively, what I said, membrane potential progressively less. This is membrane potential. Progressively less, see, minus 76, minus 72, 60, 40, 20, 0. The membrane potential progressively 0. Less. So it is reached to 0. When action potential at peak means maximum, it goes to plus 60. Plus 62. Again, it is depolarization. It is repolarization. Okay, so that the potential membrane is progressively minus 72 plus 60. This potential change is called action potential, and this membrane is called depolarized. So during depolarization, inside positive, outside negative sign. Electropositive is inside, electronegative is outside. This is called depolarization. This is called depolarization. Okay, that's all. So generally, when stimulations are applied at that moment in our body, how much electricity is generated? So here I am saying that in some books they will give 55 volts, in some books they will give 60 volts, maximum 60. Any number you can read. 55 no problem. 60, no problem. Exactly. Medicinally in our body, doctor knows. In between, I have seen, I used to refer many books. In some books, they have given 55. In some books, they give 60. So, in between that. Okay? Yes. Okay, ma? That's it. Here, finally, repolarization. 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 Depolarization. Inside is a positive, outside is a negative. Now we will discuss about repolarization. At the peak of the action potential, at the peak of the action potential, the sodium ion gated channels are closed. The sodium ion gated channels are closed. Sodium ion gated channels are closed. Then the membrane less permeable to sodium ions and more permeable to potassium ions. When it happens at the peak of the action potential, the membrane is less permeable to sodium ions and more permeable to potassium ions because the sodium ion gated channels are closed. It's a phenomenon. It's naturally when action potential is reached to maximum. So when it is reached to maximum, thereafter it should come to resting state. Okay. So at that moment, sodium ion gated channels are closed. This membrane is less permeable to sodium ions and more permeable to potassium ions. This is one statement in repolarization. Next, in this only, in another place, potassium ion gated channel. The potassium ion gated channels are opened. The potassium ions from axoplasm is expelled to outside. Potassium ion gated channel open. Potassium ion gated channel open, and the potassium ions are expelled out from axoplasm to extracellular fluid. Then inside, positive indication is progressively less, and finally it comes to original state. That is, inside is negative and outside is positive. This is called repolarization. This is called repolarization. During depolarization, the charges are shifted. The charges are shifted. Charged particles are shifted. Due to that shift, electricity is generated. Action potential is generated. So, in repolarization, the places are comes to original state. Potassium ion gated channels open, potassium ion goes out, and inside the positive indication gradually turn to negative, and it comes to original state. This is called repolarization. This is called repolarization. Okay, that's all. See here one statement. The inside of the membrane is negative. When the inside of the membrane is negative, outside is positive. This is called repolarization. This is called repolarization. Repolarization. See, while resting, potential is defined as highly potassium ions. While resting, potential is defined as highly potassium ions during resting. So, during action potential, the membrane is defined as sodium ions. Resting state, when we were in resting state, at that time, the potential is defined as potassium ions. when we were resting state, at that time potassium ions are expelled out. During action potential, it is defined as sodium ions. Sodium ions are entered from outside to inside. Almost all the neurons in our body shows different densities of sodium ions. Different densities of sodium ions and different action potentials. Different densities of sodium ions and different action potential. Okay, this point you have to remember in our body. So different places neurons are present. Those neurons shows different densities of sodium ions. Sodium ions concentration will not maintain same in all the neurons. According to that, the sodium ions action potential also change. But so one neuron maintains same action potential. So one neuron in this particular place, one neuron is there. This neuron maintains action potential is the same on entire complete neuron. So it is okay. One neuron. So from here to here, this neuron will maintain same action potential. Okay. So same action potential. How much? Maybe 55 millivolts, 55 millivolts, or 58 millivolts, or 57, like that. If we will take another neuron, that is maybe shows various. But if you will take one neuron, the action potential is same. The entire process of depolarization, repolarization, the entire process of depolarization and repolarization is very fast. Exciting and coming to resting state very fast. It takes just about 1.5 milliseconds for depolarization and repolarization. It takes